factoring special products. So there are two types of special problems that we can factor basically with mental factoring, right? You don't have to draw the X box. You don't have to split the middle. You really have limited work that you're going to show. Okay? So, take your little piece of paper, put it to the side because we'll use it a little bit later. We've got a big... All right, so the first type of problem is a perfect square trinomial. Is a perfect square trinomial. And again, perfect square trinomial, by definition, what's it going to be made of? It's going to have perfect squares in it, and how many terms? 3. So, it is a 3-term polynomial. It is a 3-term polynomial.
Also known as a trinomial.
That contains coefficients. Coefficients, sorry. That are perfect.
And what do you mean by perfect?
Well, what does perfect mean?
A square?
Yeah, it's a perfect square. 3-term polynomial that contains coefficients that are perfect. It's a little bit more than that, but we'll get there.
You mean like this kind of perfect?
I don't know what you're showing me.
I'm showing you a square. Or a rectangle.
So, jog your memory a little bit. Perfect squares. 1, 4, ladies and gentlemen, please make sure you're paying attention. 9, 16, 25, 36, 49, 64, 81, 100. I skipped something, didn't I?
No, you didn't.
7, 8, 9. I'm good. 121. It took up way less space last hour.
There's also 144.
And there's a ton of them. You need to be able to recognize perfect squares. We've been working on this skill since pre-algebra. So, we look at this. And the first question, is it a trinomial? That's pretty easy, right? Does it have 3 terms? After you say, yes, that's a trinomial, you need to ask yourself, are the first and third term perfect? Are the first and the third term perfect? Are the first and the third term perfect? Meaning, are the first and the third term one of these green numbers that we wrote down, one of our perfect squares? 2, after you say yes to that, yes, I do have a perfect first term and a perfect third term, is the middle term.
The second term?
The second term is the middle term 2 times the first and third term factors. And I'm going to put a little asterisk next to 2. What does it mean when you have an asterisk next to something? Do you know that? There's a special note about it. And we're going to put down here, or negative 2.
Negative 2 count.
Is the middle term 2 times the first and the third terms factors? So there's an asterisk. So is it 2 times, or it could be negative 2 times? I'm going to show you what this means. (9x squared plus 12x plus 4).
Number 3. What about, so what is step 3?
We'll get there. 9x squared plus 12x plus 4. Nine x squared plus 12x plus 4. Are the first and the third terms perfect?
Affirmative.
What times what equals 9x squared? 3x and 3x, correct? Don't forget your variables.
If you forget your variables, there's going to be a red
What's-
flag in your head.
Is 4 a perfect square?
Yes, 2 and 2.
2 times 2. Now we're going to look at our middle term. Is my middle term, ladies at the front, please pay attention. 2 times, what's the first factor? 3x. What's the third factor? What? 2. Does my middle term equal 2 times 3x times 2? Does that work? Yeah, that's my answer. It works. So here's my factorization. 3x, this is positive 2, and 3x plus 2. We're done. We factored it. 3x plus 2, 3x plus 2. You're done. Let's do x squared minus 12x plus 36.
Can you write step 3 on the board for me, please?
X squared minus 12x plus 36. All right, look at term 1. Is it perfect? What times what?
1 and 1. X and X.
X times x.
Almost forgot my variable.
Look at the third term, 36. Is it perfect? Is 36 perfect? What is it? 6 and 6. Then we're going to look at the middle term. is the middle term 2 times, what's the first factor? X times the third factor is 2 times x times 6 is what? 12. Is that my middle term? No, it's not my middle term. My middle term is negative 12x. So should I stop and say, no, you can't do this? Am I done? This isn't factorable? Look at step number 2. What do we put into step number 2? Gabby, what do we put? We can try negative. If I made this negative 2, does it work? Is negative 2 times x times 6. Because, ladies and gentlemen, 6 times 6 is 36, but is there another way to get 36? What? Negative 6 and negative 6. So instead of my answer being x plus 6, what's it going to be? X minus 6 and x minus 6. Four x squared minus 4x minus 1. 4x squared minus 4x minus 1. Is the first term perfect? What times what? 2x and 2x. Is the last term, the third term, perfect? Damaris, why no? Because it's negative 1. And negative 1's not a perfect square. What's the only way you can get negative 1? Negative 1 and positive 1. You could not use this trick to factor this trinomial.
That's because if you try to square root a negative, the result would be an imaginary number.
Yep, we don't have square roots of negative numbers.
They're imaginary.
So, step 3, make sure you remember to write the factors of ax, which is the first term, ax squared, which is the first term, and c in 2 binomials. Is there a shortcut to writing 3x plus 2 times 3x plus 2?
Yeah.
What is 3x plus 2 times 3x plus 2? Yeah. 3x plus 2 squared. You'll sometimes see it like that too. Well, that's okay. All right, we're putting this guy underneath. It's going to probably need to be cut a little bit at the bottom. See how that's overlapping? Don't cut the side that's folded.
So fold it in half. Everybody's going to fold it in half first.
Yeah, sorry.
You need a piece of hamburger.
Fold it like a book. And then we're going to cut the bottom part off so it fits nicely in your notebook.
We take it and we stick to it.
Yeah. I guess I don't need to. Instead of a trinomial, it's a binomial, so it is a two-term polynomial. And it contains perfect terms. A two-term polynomial that contains perfect terms. I'm also going to throw in here under perfect terms, you guys. Perfect terms mean even exponents. Because if you have exponents that are even, like x to the sixth, how do you get x to the sixth? What and what? If you have x to the sixth, what are factors of x to the sixth? X to the third and x to the third. Because remember, you add exponents together. 3 plus 3 is 6. So that means it's perfect. If you add y to the 10th, what would that be? Y to the 5th and y to the 5th. If you had z to the 12th, what would it be? Z to the 6th and z to the 6th. Even exponents. Remember our exponent rules. You add your exponents together. So 6 plus 6 is 12. So it can be factored into two perfects. The number 12 is not perfect, but when the number 12 is in an exponent, we can factor it to be perfect.
Yeah, you tell them.
Okay, here we go. You ask the same questions. Question number 1. Are both terms perfect? But I put perfect in quotation marks. And the reason I put perfect in quotation marks is because these binomials are always subtraction. These binomials are always subtraction.
What if it's addition? It's not that it won't work.
If it's an addition problem, this trick doesn't work for it. So you're going to factor, but make sure the second term is factored with one positive and one negative.
It's like a proton and an electron coming together to form a hydrogen atom.
Sure.
Because one has a positive charge and one has a negative charge.
Or it's a negative perfect number.
So it's like the atom of a perfect square binomial.
All right. If that makes sense to you and how you want to think of it, go for it. Let's try 16x squared minus 4. Are both terms perfect? Let's look. What are the factors of 16x squared? What and what? What? 4x and 4x, correct? Now, the last time we did one of these problems, I said -4 wasn't perfect, or Demara said -4 wasn't perfect, and I agreed with her. -1 didn't work. Why does -4 okay? Because it's always going to be a subtraction problem, so we're good there. It's -4. So in this one, since it's a binomial, I factor it with one positive and one negative. So what times what is -4? 2 and -2. So the answer is 4x plus 2 and 4x minus 2. And we're done. We factored it. Because what you used to do to this problem is you used to make it 16x squared plus 0x minus 4. And then you would factor it. You can still do that. And then X box it. Or split the middle.
Or X split.
But since they're both perfect, I don't have to go through that. I can just easy does it. Cameron, pay attention instead of talking. Let's try another one. 1 minus 25y to the 8th. One minus 25y to the 8th. Are they both perfect? What's 1? 1 times 1. What's 25y to the 8th? Negative 25y to the 8th. 5y to the 4th and negative 5y to the 4th. One has to be positive and one has to be negative because I have a negative number. The only way to get a negative value is a positive times a negative.
Negative times a negative, double negative, can't figure out.
So I have 25, which is perfect, but it's minus 25. So 5 and negative 5. So my answer is 1 plus 5y to the 4th and 1 minus 5y to the 4th. And I'm done. If that doesn't make sense to you, you can do negative 25y to the 8th plus 0y plus 1. You can make it a trinomial, split the middle, or X box. This is just a faster way of doing it. Uh, 49x to the 4th plus 100y to the 3rd. $49x to the 4th. Does it work? 49, is it perfect? And is it an even exponent? So I get 7x squared and 7x squared. I'm good. What about 100? Y to the negative 3rd. Okay, there's a lot of problems here. We cannot do this one. The first reason we can't do it, Gabby, why'd you say? It's not a subtraction problem. So that should be our first reason of why we can't use a special product rule. What's the second reason we can't? Y to the third is odd, meaning it's not perfect. Exponents have to be even in order to be perfect.